All right, in section 3.4, we're going to look at two different rules, the product rule and the quotient rule. We'll basically use the product rule to take derivatives of functions, and also we'll look at the quotient rule and how to take the derivative of any function using the quotient rule there. All right, earlier we already done some of the techniques for differentiation using the power rule, the constant rule, and also the constant multiple rule, and the sum and difference rules. And we talked about some other rules for taking derivatives. So here, we'll only focus on the product rule and the quotient rule. We'll start with the product rule. So here, if we have two functions f and g, and if they're differentiable at x, then the derivative of the product of these two functions, f of x and g of x, is going to be expanded as this: f prime of x times g of x plus f of x times g of x. Now, the way I would do that for taking a derivative, I would say, in this case, the derivative with respect to x of the first times the second, that would be something like this. Take the first times the derivative of the second, and then add to it the second function times the derivative of the first function. Okay? Again, first times the derivative of the second plus second times the derivative of the first. Okay? So in this first example, we're going to use the product rule to find the derivative of each of the following. In this case here, I got y is equal to 4x squared minus 8x plus 8 multiplied by e to the power of x. So this is what I would do here. I will let this first factor be the first, and then e to the x will be the second. So in this case here, if the first is going to be 4x squared minus 8x plus 8, and then the second would just simply be e to the x. Here's what I'll do. I'll take f prime, which is our first which is the derivative of the first function, and we should know how to take the derivative of a sum and the difference. We just take the derivative of each individual term. So in this case here, for 4x squared, that would be 8x for its derivative, and then the derivative of minus 8x will be minus 8. And of course, the derivative of 8 is going to be 0 because the derivative of a constant is 0. And then the second was e to the x. Well, that's the easiest derivative to take. So here s prime, which will be simply e to the x. And then I go ahead and apply that product rule where, in this case here, I'll say y prime is going to be the first times the derivative of the second plus the second times the derivative of the first. So in this case here, I'm going to have y prime, that's equal to the first term, which is that 4x squared minus 8x plus 8. And that's times the derivative of the second, which is of course e to the x, and then plus the second, which is again e to the x, times, and I'll put these in parentheses here, times the derivative of the first, which is in this case 8x minus 8. And then I'm going to try to simplify this a bit. Now what I'm going to do here is factor out e to the x, because e to the x is in this term, and e to the x is in this term as well. So let's go ahead and factor out e to the x. And if I factor out e to the x, then what's going to be left in this first term would be the 4x squared minus 8x plus 8, and then plus, yeah, I don't need the right parentheses here, and then plus, if I factor out this e to the x, I'm going to be left with 8x minus 8. Now, it's going to be easier for me to simplify what's inside the parentheses here. So I brought down the e to the x. So here, if I simplify, that minus 8x and that plus 8x, that's gone. And then plus 8 and a minus 8, that too is gone. I'm only going to be left with just simply 4x squared. So I got e to the x times 4x squared. And in this case here, if I simplify that, well, if I put the 4x squared in front, I'll just have 4x squared times e to the x. So that's going to be the derivative of this function for y using the product rule. Okay. All right, here's another example, part B. In this case here, we got y is equal to 2x minus 9 times 6x squared minus 5x plus 2. And here I want to find the derivative of that particular function using the product rule. Well, here, I'm going to let that 2x squared minus 9 be the first function, so that's what f is. That's going to be the 2x squared minus 9. And I'll go ahead and take the derivative of that first function. So here, f prime, if I take the derivative of 2x squared minus 9, I'm going to end up with 4x. And then the second is that 6x squared minus 5x plus 2. So in this case here, if I take its derivative, which is going to be s prime, that would be the derivative of the second function. Here, 6x squared, its derivative will be 12x. Minus 5x, its derivative is going to be minus 5, and the plus 2, its derivative is 0. Okay, so this is what I have here. And now I can go ahead and take the derivative using the product rule. So here y prime would be, again, the first times the derivative of the second plus the second times the derivative of the first. So here y prime would be, the first was that 2x squared minus 9 times the derivative of the second. The derivative of the second there was 12x minus 5. And then plus, and then the second was that 6x squared minus 5x plus 2 times the derivative of the first, which is in this case 4x. And now I'm going to simplify this first term, or this first product, using the FOIL method. So in this case here, when I do 2x squared times 12x, that's going to be 24x cubed. And then 2x squared times the minus 5 will be a minus 10x squared. And then minus 9 times 12x will be a minus 108x. And then minus 9 times the minus 5 will be plus 45. Now for this right here, I'll go ahead and distribute the 4x over the 6x squared, the minus 5x, and the plus 2. So if I do 4x times 6x squared, that would be 24x cubed, and it'll be plus 24x cubed. And then 4x times the minus 5x will be a minus 20x squared. And then 4x times the plus 2 will be plus 8x. Now next I'll go ahead and try to combine some like terms if I can here. Well, I got 24x cubed and another 24x cubed. If I add those up, I'll get 48x cubed. and then minus 10x squared and a minus 20x squared will be a minus 30x squared. And then negative 108x and a plus 8x. Well, negative 108 plus 8 will be a minus 100, so it'll be a minus 100x. And I have nothing to add to the plus 45, so just bring that down. So y prime will be 48x cubed minus 30x squared minus 100x plus 45. And that would be the derivative of that particular function using the product rule. Okay. All right, now let's look at another example, part C. Here again, y is equal to x minus 1 times x cubed plus x squared plus x plus 1. And I want to apply the product rule for this particular function. Well, I'm going to let the x minus 1 be the first, and this x cubed plus x squared plus x minus 1, that would be the second. Okay. So if the first function would be x minus 1, its derivative, which I'm calling f prime, would be 1. And then the second function is going to be that x cubed plus x squared plus x plus 1. So the derivative of that, which I'm going to call s prime, would be 3x squared plus 2x plus 1. Derivative of x cubed is 3x squared. The derivative of x squared will be 2x. The derivative of x will be 1. And the derivative of 1 will be 0. Alright, so now we can apply that product rule here. So the y prime will be first times the derivative of the second plus the second times the derivative of the first. So in this case here, I'm going to have y prime will be the first, which will be x minus 1, times the derivative of the second, that's the 3x squared, plus 2x plus 1, and then plus, and in this case here, the second would be the x cubed plus x squared plus x plus 1, and that's multiplied by the derivative of the first. Well, the derivative of the first would be 1. And now we're going to simplify all of this and try to combine some like terms here. For the x minus 1 times 3x squared plus 2x plus 1, I have to multiply each term of the first factor by each and every term of the second. So if I do x times 3x squared, that would be 3x cubed. And then x times 2x will be a plus 2x squared. And then x times the 1 would be a plus x. And then I'll do minus 1 times each term of the second. So minus 1 times 3x squared will be a minus 3x squared. Minus 1 times the 2x will be a minus 2x. Minus 1 times the plus 1 will be minus 1. And then I'm going to distribute the 1 over each and every term here. So 1 times all of this will be this. 1 times x cubed would be a plus x cubed. 1 times x squared would be plus x squared. 1 times x will be plus x. And then 1 times 1 will be 1. And let's see if we can combine like terms here. Well, I got 3x cubed and an x cubed. Well, 3x cubed and a 1x cubed would be 4x cubed. And now 2x squared minus 3x squared would be negative x squared, and then I got a plus x squared right here, so that 2x squared with this x squared along with the minus 3x squared, that's gone. Plus x is 2x, but I also got minus 2x here. So these x's will give me 2x. That goes away with the minus 2x. And then minus 1 and a plus 1, that's gone. I'm going to end up with 4x cubed as the derivative of this particular function, applying the product rule. Okay, here's another one. Here we got g of w is equal to e to the w times the quantity 5w squared plus 3w plus 1. And I'm going to try to find the derivative of that particular function applying the product rule. In this case here, the first will be e to the w, and then the second will be 5w squared plus 3w plus 1. Well, if I let the first be e to the w, then its derivative would be simply e to the w. Okay, e to the x or e to the w, that's the easiest derivative to take. And then the second was 5w squared plus 3w plus 1. And its derivative, which I'm calling s prime, is this. For 5w squared, its derivative is 10w. For the 3w, its derivative will be plus 3. And of course, for the plus 1, the derivative of that will be 0. And now I can find what g prime of w is applying the product rule. And of course, that's going to be the first times the derivative of the second plus the second times the derivative of the first. So in this case here, the first was e to the w times the derivative of the second, that's 10w plus 3, plus the second, which is at 5w squared plus 3w plus 1 times the derivative of the first, and that's e to the w. Well, it would be easier for me to factor out e to the w since it's in both of these products here. So if I factor out e to the w, this one what I'm going to have here. In this first term, I'm going to have 10w to the third, 10w plus 3, and then plus. Factor out the e to the w, I'm going to have 5w squared plus 3w plus 1. And now I'm going to combine like terms in the bracket here. So I have e to the w on the outside. And I'm going to put the 5w squared first. I'm just going to put these in descending powers here. 10w plus 3w will be plus 13w, and then plus 3 plus 1 would be 4. So this will end up being e to the w times the quantity 5w squared plus 13w plus 4. That would be your derivative of g of w using the product rule. All right, next is here you're given the function y is equal to t squared plus 7t times 3t minus 4. We're going to do two things. Use the product rule to find the derivative of the given function and simplify the results. And then number two, you're going to find the derivative by expanding the product first, and then verify that your answer agrees with number one. Okay, so let's start off. All right, let's start off by using the product rule. Okay, we're going to start by using the product rule here. That first function, the first product will be, or the first factor will be t squared plus 7t. T squared plus 7t. And then the second would be that 3t minus 4. Well, in this case, if the first is going to be the t squared plus 7t, the derivative of the first would be just simply 2t plus 7. And if the second is just the 3t minus 4, then the derivative of the second would just simply be 3. And now we can find what y prime is going to be equal to. That's the first times the derivative of the second. The first is your t squared plus 7t. That's multiplied by the derivative of the second, which is 3, plus, and then the second times the derivative of the first. The second is your 3t minus 4 times the derivative of the first, which is 2t plus 7. And then we go ahead and simplify all of this. We will distribute the t over the t squared plus 7t. So 3 times t squared would be 3t squared, plus 3 times 7t will be 21t. For this, we have to use the FOIL method. So in this case, 3t times 2t will be a plus 6t squared. And then 3t times the plus 7 will be plus 21t. And then minus 4 times 2t will be a minus 8t. And then minus 4 times 7 will be a minus 28. And now let's combine some like terms here. 3t squared and a 6t squared will be 9t squared. 21t plus another 21t is 42t. 42t minus 8t would be a plus 34t. And then we bring down the minus 28. So this will be your derivative using the product rule. Y prime will be equal to 9t squared plus 34t minus 28. Now let's try to expand this first and then take the derivative. So that's part B. So we got the y is equal to t squared plus 7t times 3t minus 4. Well, of course, we're going to use the FOIL method to expand this. So t squared times 3t will be 3t cubed. And then t squared times minus 4 would be a minus 4t squared. And then the inside would be 7t times 3t will be a plus 21t. And then 7t times a minus 4 would be a minus 28t. And then let's see here. I think I left something out here. 7t times the 3t, that's 21t squared. And now we can combine like terms here. So the y is equal to 3t cubed minus 4t and a plus 21t will be a plus 17t squared. And then bring down minus 28t. And then next we can go ahead and take the derivative of y. So this will be y prime is equal to, if I take the derivative of 3t cubed, that will be 9t squared. And then plus the derivative of 17t squared, well, 2 times 17, that would be 34. Write down the t, and it's going to be to the 1 less power. And then minus the derivative of 28t will be 28. And as you can see, when we expand this, we do get the exact same answer. And I should have labeled this as number 1 and that as number 2. I'll go ahead and do that. So you see, the answer that I got in number 1 and in number 2 are the same. Okay. So that's the product rule. Now we'll look at the next rule, which is the quotient rule for taking derivatives. Now the quotient rule states this: if you have f and g and they are differentiable at x and g of x is not equal to 0, then the derivative of f over g at x exists, and its derivative will be this: g of x times f prime of x minus f of x times g prime of x, all divided by g of x squared. Now, an easy way to remember the quotient rule would be something like this: the low times the derivative of the high minus the high times the derivative of the low, and all of that's over the square of the low. Another way you can remember that would be this: I remember it as taking the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, and that's all over the denominator square. Okay? Because this is denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the square of the denominator. All right, now let's apply that quotient rule to some examples like this one. Let's say we've got the function f of x is equal to 9x minus 6 over x minus 6, and I want to apply the quotient rule to find its derivative. Okay? So here I'm going to let the high be the numerator, 9x minus 6, and then the low will be the denominator, x minus 6. Well, if the high is going to be 9x minus 6, then the derivative of the high would be just simply 9. And the low is x minus 6, so the derivative of the low would be 1. So here f prime of x will be this: low times the derivative of the high. So your low is your x minus 6. The derivative of the high would be 9 minus the high times the derivative of the low. The high is 9x minus 6 times the derivative of the low, which would be 1. All of that will be divided by the square of the low, which is your denominator, x minus 6. And now we can go in and simplify all of this. Let's see, distribute the 9 over the x minus 6, you're going to get 9x minus 54. Now, keep in mind, this negative is going to change the sign of each and every term here, and I'm distributing the negative 1 because of that minus sign. So that minus sign makes the 9x minus 9x. The minus sign makes the minus 6 a plus 6. All over, I'm going to leave that x minus 6 quantity square as is. And now let's combine some like terms here. That 9x and the minus 9x, that's gone. Negative 54 plus 6 will give you a negative 48. So the numerator will be negative 48, the denominator will be x minus 6 quantity square. And that will be the derivative of that particular function applying the quotient rule. Okay? All right, part B. That f of x is equal to 5x squared minus 9x plus 6 over 3x plus 2. And I'm going to apply that quotient rule to find the derivative here. So here, the high is going to be the numerator, that 5x squared minus 9x plus 6. And the low would be the denominator, 3x plus 2. Well, if the high is going to be the 5x squared minus 9x plus 6, the derivative of the high would be, in this case, 10x minus 9. And if the low is your 3x plus 2, your derivative of your low would be 3. So now the quotient rule is this. So f prime of x would be the low, which is your 3x plus 2, times the derivative of the high, that's that 10x minus 9, minus the high, which is of course that 5x squared minus 9x plus 6. I'm going to leave some space here, because I'm going to put in front of it the derivative of the low, which is just a constant. That's just going to be 3. So I'm putting a 3 in front. And then all that's going to be divided by the square of the low, 3x plus 2 quantity square. And now let's simplify all of this. Bring down the f prime of x. I'm going to have to use the FOIL method with the 3x plus 2 times x, 10x minus 9. So 3x times 10x will be 30x squared. 3x times a minus 9 will be a minus 27x. And then 2 times 10x will be a plus 20x. And then 2 times the minus 9 would be a minus 18. And then distribute that negative 3 over all of this inside the parentheses. If I do negative 3 times 5x squared, that's going to be a minus 15x squared. And then minus 3 times the minus 9x will be plus 27x. And then minus 3 times the plus 6 will be a minus 18. And all that's going to be divided by 3x plus 2 quantity squared. I'm not going to expand this out. Now let's combine some like terms if we can. Alright, in this case, I'm going to bring down the 30x squared. Let's see, minus 27x and a plus 27x. That's gone. And I got the 20x. The plus 20x, I'll go ahead and bring that down. Wait, no, I'm missing something here. 30x squared and a minus 15x, I can combine that. That's going to give me 15x squared, so I need to wipe that out and say that's 15x squared. And then the plus 20x, I can't combine anything with that. Minus 18 and a minus 18, that's a minus 36. And all of that will be over 3x plus 2 quantity squared. So that's what f prime of x is going to be. 15x squared plus 20x minus 36 over 3x plus 2 quantity squared. And that's the derivative for that particular function using the quotient rule. And I don't think I can factor 15x squared plus 20x minus 36 here. Okay. Alright, part C. Got f of x is equal to 8e to the x over e to the x plus 7. So here I have a quotient rule that I'm going to use, and I'm going to use an easy derivative here. So, if the high is going to be 8e to the x, that's the numerator, the derivative of the high is also 8e to the x. Here I'm using the constant multiple rule, bring the constant over and take the derivative of e to the x, which is e to the x. And the low, which is the denominator, is e to the x plus 7. So the derivative of that low is going to be, well, the derivative of e to the x is e to the x. The derivative of a constant, which is 7, that's going to be 0. So now I can find its derivative here, which will be, let's see, low times the derivative of the high. That's the e to the x plus 7 times the derivative of the high. That's 8e to the x minus the high, which is going to be 8e to the x, times the derivative of the low. Well, the derivative of the low is e to the x. And all of that will be divided by the denominator, or the low, e to the x plus 7, and that's going to be squared. Alright, what I can do here is factor out 8e to the x. There's a common factor here. I can factor out that 8e to the x. And when I do that, this is what I'm going to have. Take out the 8e to the x, I'm going to be left with e to the x plus 7. And in this term, if I take out 8e to the x, I'm going to have a minus e to the x. And all that's divided by e to the x plus 7 quantity squared. I'm going to simplify what's in the parentheses in that numerator. E to the x and a minus e to the x. That's gone. So those e to the x's are gone. I'm left with 8e to the x in the numerator times 7 over e to the x plus 7 quantity squared. And then 7 times that 8 will be 56. So I have 56 e to the x divided by the quantity e to the x plus 7 squared. And that would be the derivative of f of x using the quotient rule. Okay. All right, now part D. Here we got y is equal to 3t plus 1 times 4t minus 5, and that's raised to the negative 1 power. And here I want to apply the quotient rule here. Well, notice I got 14 minus 5 and it's raised to a negative power. I can write that using positive exponents here, okay? So here I can write that as y is equal to, the 3t minus 1 will be in the numerator, but that 14 minus 5 will be in the denominator. So here I'm using the rule for exponents, where if you have a to the power of negative m, I can write that as 1 over a to the positive m. I'm putting a 14 minus 5 in the denominator here. And now we can take its derivative here. So here, the high is the denominator, the numerator, 3t minus 1. So the derivative of the high would just be 3. The low is your denominator, 14 minus 5. So the derivative of the low would be just simply 4. And now let's find y prime. Again, that's going to be the low times the derivative of the high, so it'll be 14 minus 5 times 3 minus the high times the derivative of the low. I'm going to put the 4 in front of 3t minus 1 because that's the high times the derivative of the low, all divided by your low, which is 14 minus 5 quantity squared. So again, low times the derivative of the high minus high times the derivative of the low, all divided by the square of the low. And we'll finish this off. Distribute your 3 over the 4t minus 5. You'll have 3 times 4t, which will be 12t, minus 5 times 3 will be 15. Now that minus sign changes the sign of each and every term, so we're going to do minus 4 times 3t, which is a minus 12t, and then minus 4 times the minus 1 would be a plus 4, all divided by 4t minus 5 quantity squared. Now if I simplify the numerator, the 12t's are gone. And then you got negative 15 plus 4, which will be negative 11. So you'll end up with negative 11 over 4t minus 5 quantity squared. Okay, so that's going to be the derivative of that particular function using the quotient rule. In part E, you got f of x equal to e to the negative x times the square root of x. Okay, now, the e to the negative x is to a negative power, so I'm going to put the e to the x in the denominator and make it positive here. So this will be f of x equals to, that square root of x will be in your numerator. E to the negative x will convert to e to the positive x, as you can see. Alright, in this case, this time a high is going to be the square root of x. Well, the derivative of the high, now if you recall in one of the sections where I showed you how the derivative of the square root of x is, it's going to be 1 over 2 square root of x. I pretty much talked about that in Wednesday's class. So if the low is e to the x, your derivative of your low is simply, again, will be e to the x as well. So now we can go ahead and take the derivative using the quotient rule here. So here f prime of x will be the low times the derivative of the high. So the low is e to the x multiplied by the derivative of the high, which is 1 over 2 square root of x, minus the high, which is square root of x, times the derivative of the low, e to the x. And all of that will be divided by the low, which is your e to the x, and that's going to be squared. So here f prime of x. In the numerator, I can factor out e to the x. That's what I'll do here. Factor e to the x out. And then what I'm going to be left with is 1 over 2 square root of x minus the square root of x. Okay. And in the denominator, I'm going to break up e to the x because e to the x is used as a factor twice. So I'm going to write that as e to the x times e to the x. And as you'll see here, one of the e to the x's will divide out in the numerator and the denominator. So here I'm going to be left with, let's see, 1 over 2 square root of x minus the square root of x, all divided by e to the x. And you're going to have to excuse my not so good handwriting when I'm doing this here. And then I'm going to go ahead and do this. I'm going to pull that e to the x out of the denominator and make it a negative exponent. So it'll be 1 over 2 square root of x minus the square root of x times e to the negative x. And then distribute e to the negative x over these two terms here. So this will end up being 1 over 2 square root of x times e to the negative x minus the square root of x times e to the negative x. and that will be your derivative of that particular function. Okay, I'm going to end this video right here and go over the extended power rule on the next class session. But I will open up the homework, which will only deal with just the product and the quotient rule. And then the rest I will cover in class on Monday. So this should be enough to get you through the homework on section 3.4. So don't forget about there will be a quiz that will be opening up shortly, so be aware of that. And I will be posting some announcements on Cruiser as well. All right, thanks for listening, and have a good weekend.